AP, this is a continuation of section 12.5. We're going to look at some more advanced reaction mechanisms. So when an intermediate is a reactant in the rate determining step, we have to derive the rate law, which is a bit more difficult. So our overall reaction is NO2 plus CO yields NO plus CO2. So the first step is the fast step, which is NO2 plus NO2 yields NO3 plus NO. And then the second step is our slow step, NO3 plus CO yields CO2 plus NO2. So what do we do when the slow step is not the first step? We are still going to write the rate law based off of our slow step. So I'm going to write rate equals K, concentration of NO3 times the concentration of CO. But this is not an accurate rate law for our overall reaction because, as you can see, NO3 is not in the reactants or in the products. So what this means is that NO3 is an intermediate. And because it's an intermediate, it can't be in the rate law. So what we are going to do is we are going to solve for what NO3 is equal to in the fast step. So what I want you to do is I want you to pretend that these plus signs are multiplication signs and your reaction arrow is the equal. So we want to solve for NO3. So that means that I need to divide both sides by NO. Cancels out over there. Gives me that. So NO2 times NO2 is divided by NO is equal to NO3. So what I'm going to do is I'm going to plug this into the rate law that I wrote off of the slow step that contained the intermediate. So I'm going to rewrite this as rate equals K times concentration of NO2 times the concentration of NO2 divided by the concentration of NO. That should just be NO, not NO2. Times the concentration of CO. Now we can simplify this down further to be the rate is equal to K times NO2 squared times CO divided by NO. And this would be the rate law for our overall reaction. So our second more advanced rate mechanism, or reaction mechanism, we have the overall reaction of Cl2 plus CHCl3 yields HCl plus CCl4. So the mechanism that is proposed, the first step is the fast step, Cl2 yields 2Cl. And then the slow step is the second step, Cl plus CHCl3 yields HCl plus CCl3. And then a third step, the fast step, Cl plus CCl3 yields CCl4. So again, I'm going to write the rate law based off of the slow step. That's what you always want to start with. So Cl times the concentration of CHCl3. Now, when we look at our overall reaction mechanism, we have the CHCl3, but we don't have chlorine. So this means that chlorine is an intermediate. So again, I'm going to look at that first step, that is the fast step, and I want to solve for Cl. Now, in this reaction, it's a little bit different than the last reaction because we only have one reactant and one product. So we already have Cl by itself, but we have the coefficient 2. So in order to solve for one Cl, like what is in our slow step, we need to divide this by 2, which means we also need to divide this side by 2. So that means that we're going to have 1/2 Cl2 is equal to Cl. And I'm going to plug this into my rate law for Cl. So I'm going to have the rate is equal to K, and I'm replacing Cl with Cl2, but the coefficient on Cl2 is 1/2, so I'm going to take the concentration of Cl2 and raise it to the 1/2 power times the concentration of CHCl3. And this is my overall rate law for this reaction. So we're going to stop there and we will pick up the model for chemical kinetics in another video. Thanks. Have a great day.